Hello, everyone. I guess you're here to learn about BGP. Before I start, I have some quick questions just to help me understand what people are looking to get and what level you're at. How many people here have configured BGP on a device in the past? How many people have BGP running on more than one router? More than one POP? More than two transit providers? Okay. How many people have ever used their laptop to configure a router while in the bathroom? To debug or fix connectivity problems? Okay, just checking. So we have some operators and some architects and some other people. So I'm going to give an intro to BGP. The second talk covers, and this is fairly introductory level, ground level stuff about BGP, the protocol, the attributes in BGP, how routers peer with each other, how basic multi-homing works. In the second talk, we'll talk a little bit about how to scale with BGP. Some of the original design of BGP didn't scale well when people actually had to go to 20, 30, 40, 50 router networks, multiple POPs, do load balancing and things like that. We'll also talk a little bit about load balancing. And if anyone in the second talk would like to volunteer their network, we could actually log in and try to do some traffic load balancing. Or if I have some time, maybe I'll set up a victim router and some victim news traffic, and we can experiment with that. How many people have more than 20 routers in their network? More than 10? Okay. So we'll talk a little bit about what it means to be connected to the internet just in general, how the address reachability works, multi-homing without BGP, how it works with your address space with your provider. A little, and then go into BGP talking about routes and how you create BGP routes, advertising them to other providers, how you pick which routes you like from different providers, talk a little bit about hardware, and then we'll break the next BGP talk. We'll talk a little bit about how to scale. Peer groups and clearing routes and selecting traffic and route reflectors and things like that. How many people have their own address space? IP address space? How many people only use their provider's address space? Okay, so we have a few people. So to have internet connectivity, you have to be able to reach everyone, and more importantly, they have to be able to reach you. So it's actually pretty interesting when you look at BGP configuring it and load balancing. There's the Gazinta and the Gazouta. There's how do you get yourself heard. So routes go out and traffic comes back. And then you hear routes, or you may just hear a default route, and then based on that, you select traffic. It's very easy to get your outbound packets going. You can statically route default route, you can take BGP, you can do lots of things. The trick is to make sure that everyone hears the routes that you're advertising or that you have your providers advertising for you. So normally if you're not multi-homed, you have address space from them, and they're announcing a bigger address chunk, and then they give you some of it, and they take care of all that for you. So without BGP, that's exactly how it works. Your providers say, here I am. The provider has a 17, and if my customer has a 24, then I don't need to announce it separately. No one needs to know that I also have that 24 because there's no other path. The only time that anyone needs to know about your specific address space is when there's multiple paths. So the coming impending doom of the internet is what happens when IPv6 continues to not be widely enough adopted for people to shut off connectivity except via v6, and then address space is only available in small chunks, and everyone has to announce this space even if they didn't need to be massively multi-homed, and then we have problems with routing tables. But hopefully we won't get there. We'll see what happens. It'll definitely be a couple interesting years. So when you're not running BGP, your providers are worrying about how their address space gets announced. You don't have to worry about that. And you can just default route to them, and they'll make sure that the packets get to everywhere. So when you're doing route advertisement, as with all routing, the most specific route wins. For people that have trouble remembering that, we just point out if that didn't work, then 0.0.0.0 would be better than 127.0.0.1, and you'd never be able to talk to yourself. So the smallest set of IP addresses is always going to be the best path, otherwise the best way. Otherwise, the router's IP routing basically couldn't work. So if I am going to multi-home and I have a 24 inside of a 17, I have to have that 24 be heard not only from the new provider, but also from the old provider. So that's called deaggregating or cutting a hole in your filters or block, and then you have to, your provider has to do something. So your first provider is going to be aware of the fact that you're multi-homing, which is just something to note if you're behind on your bill to them, that may be a time that they get you to come current, because people definitely get much more nervous when your customers are multi-homed. And what they have to do is a little bit of router configuration work, or if you have multi-homed customers, how many people have multi-homed customers, run networks that have themselves that you guys have multi-homed customers? Anyone? Okay, so a few people. So this is something that you, when you set up your network, need to just think about what it would look like in your configs when you have customers that come to you and say, hey, I need to take this 23 and announce it. You just need to make sure that you've, it may just be adding it to a prefix list. It may be that you have a configuration management system or a database. You just need to think about what happens. And then both providers announce the 24. Only the provider that has the 17 announces it. Hopefully your second provider is not going to be clueless and try to announce more address space than you have. Hopefully they're doing some sort of sanity check, and you're doing SWIPs and registering address space, but that's basically the way that it works. So all you need to do if you're getting address space, if you're not running BGP, is you get some default routes and you load balance. Or again, you could even just statically balance. You could put some routes in and either do route caching, which is the default way that, say, Cisco's will work, where you put in multiple routes to the same destination, and it'll send traffic to that's destined to a given IP address always to that destination for some period of time. Because what you don't want to have is a TCP session with every other packet going out multiple pipes on the internet. Then you'll have reordering and different kinds of loss and latency, and things will get very unhappy. So the default way that will work on most devices, if you put in parallel routes with equal metrics, equal goodness, is that it'll lock in certain destinations go on one pipe. Or you could say one pipe is primary, and then you can put in a cost that's higher to say only use this other one if the first one goes down. And one may be more expensive, or you may have two routers and do weird load balancing, again, because you don't want to get into running active load balancing. And how many people run all Cisco for external routing? All Juniper? And then Mix? All Ascend Maxes? Proteons? PC routers? GateD? Zebra? Okay, some people are not raising their hand. So, again, I keep getting ahead of myself. So the way that most routers and switch routers work, and I would say that probably the most common that we see in the data center external device is the Cisco 6500, 7600. It's a SOUP 720. Hopefully you're not running a SOUP 2. How many people are running SOUP 2s for BGP? I actually have one that requires special filters to make sure it doesn't blow its little cookies. And because it can only have 240,000 routes without, going into having Ceph problems. So, Cisco switch routers are effectively routers. You can tell the difference between a router and a switch router if you look at what happens with a VLAN. If you define a VLAN and it is the same VLAN 50 on all ports, then it's really a switch. If you define a VLAN on a port and it stays on that port, then it's really fundamentally a router. So most things that most people use for cheap 10 gig nowadays are really switch routers. So Foundry, I guess I forgot to mention Foundry and Extreme and Force 10 and other things that people use. So Foundry and Cisco, fundamentally, they have different ways of doing it, but you define a VLAN, it's that VLAN for the whole switch. You have to do some work to actually make it be. But if you looked at the older Ciscos or you look at the Juniper routers, then you can have VLAN 50 on multiple ports, and they're actually different definitions of that VLAN. So generally speaking, what all these devices do is they do some sort of route caching. They could either just simply do destination IP, or you can do MAC address, or you can do IP and MAC, or IP and port, different kinds of hash policies if you're trying to do different kinds of load balancing, either internally inside your network or to the outside world. If you do route caching, then for any given TCP session, all the packets are going to go out the same pipe, and you should generally get pretty even load balancing. If you don't use route caching, then you're going to be doing a round robin, and that presents problems. The only time that you really want to be doing just round robin load spreading of packets is if you have parallel circuits that are the same latency, that are between the same two devices, basically LACP ether channel type stuff. And even then, people generally do hashing. The trick is just finding a hashing algorithm that directs enough traffic. For example, one of the common topologies that people have problems with is they have, let's say, four GigEs bonded from one POP to another, but there's two external border routers in the remote POP, and their hashing is based on the destination MAC address. So they effectively, from the perspective of the device doing that hashing, they only have two destinations, and if both of those destinations get locked into one of the 4 GigEs, then you have a problem. So that's where you want to look for different kinds of hashing that you can do that take into account IP address and port and things like that. But generally speaking, you add multiple routes, the router is going to do the right thing, or the switch router is going to do the right thing, and you get reasonable load balancing. So if you're multi-homing without BGP and you want to get packets to come into you, you don't really have a lot of work to do. You've gotten the address space from someone, they've presumably swipped it to you, and your new provider is going to do some amount of due diligence, we would hope, to validate that it's your address space and not typoed, and then they take care of it. If it needs to be in a routing database, a routing registry, they'll typically do that entry for you if you're not running BGP and magically make it happen. And then the last thing is you need address space. You could get it from them, or you could get an ASN, you can get address space. But it sounds like most people have already gone through that hurdle. How many people are primarily dealing with ARIN? RIPE? APNIC? Other? So, okay, Skype is still bugging me. How many people have registered their routes in routing registries so that their providers can hear the routes? Okay, so we'll talk a little bit about routing registries. One of the challenges that we face when we actually try to look at the internet routing table is there is no authoritative state of the internet. No one really knows who should be advertising what. And there's a philosophical divide that's been going on for 12 or 13 years between the people who think that it should just be possible for everyone to attest to the routes that they have and the relationships that they have, and then to be able to build filters on the whole internet. And then there are people who say those things are so useless and so full of bad data that it doesn't really matter and we shouldn't even bother. You can see this effect when you do a who is, which effectively is a who was. It's like who was that address space when it first got registered, and then often it never gets updated. Routing registries have the same thing. Usually there are these databases that people register their intentions, which may never actually happen. I intend to buy transit, I intend to peer with this person. People used to get off on, pretending to peer, I intend to peer with Unet, Sprint, and, WorldCom and everyone else, and then they never did, but, those are in there. So you look at the routing registries and they don't really reflect reality, and you say, what's going on? Well, the challenge is your providers are typically not, your providers don't have good enough routing databases to be able to build filters on each other, right? There's level 3, for example, if you use them as a provider, has a routing database, and you're not going to be able to get your route into them unless you register in it. But it's not actually a good enough database for anyone to be able to build a filter on everything that level 3 is announcing. The goal is that if you are a relatively small customer, that level 3 can say, I'm not going to allow anything I'm not going to allow you to advertise anything for me unless your AS has put something in that database. And it's just a way with a system of enforcing those constraints. And the goal is that most of that filtering on the internet is done at the edge. So again, the medium-sized, and the larger providers don't actually filter each other. They may have max prefix filters to say, I don't want to hear more than so many routes, but they're not actually looking into a list of every route because no one knows what routes should be advertised. But you, when you go to advertise routes in BGP, are going to have to typically enter your route into a routing registry as specified by your provider, or the favorite is AltDB. How many people use AltDB right now? So AltDB is a free routing registry that a lot of Tier 2s use to build from. So you have to register your AS if you have one, your customers and their ASs, and then the routes, and then people typically have scripts that build their configurations for their Ciscos or Junipers that build those filters on you. And then they filter it at the edge. And then in BGP 102, we'll talk a little bit about what they do when they hear the route from you, so that in a large scalable way they can say, hey, that route is mine within their network, so they know how to do the correct things. And if you don't want to run your own routing registry, you can use others, you can run scripts. There's a lot of tools out there to be able to use that. At the smaller level, you know, people typically don't bother with it. When you're at the point where you have 10 customers that are multi-homed and 30 prefixes, typically people just maintain that with access lists on their devices. So the providers are going to do advertising. If, let's say that you had address space from nLayer originally and it was a 17, we talked about this, and then Sprint says, oh, I have the 24, what's going to happen? All the traffic's going to come in via Sprint. So what you have to do then is have nLayer say, oh, I also have the 24. So they're going to announce their 17, they're going to announce the 24, and then different people are going to prefer different paths. Another thing we'll talk about is how you can change how much traffic goes in which port. The thing to remember is, because you can always select your outbound route by just using static routes, no one can absolutely select their inbound, because your outbound is their inbound. So the trickiest thing to do is to get your inbound correct while being friendly to the internet. You can make yourself look a little bit further away, but ultimately the only thing you can reliably do is deaggregate your announcement. So announce a 23 in both places, announce a 24 in one place, but that's considered unfriendly because it causes work for the routing table. So we'll talk a little bit about that and some of the things that you can do. So why would you want to run BGP or not run BGP? Is anyone multi-homed without BGP right now? Multiple providers, no BGP? Okay. So it turns out that if you're not very good at running networks and you use unstable hardware, that some people, there is a class of people that are better off actually multi-homing but not using BGP. Because you can actually cause yourself a lot of damage if you're trying to change route maps and prefer traffic and you're not doing it properly and you're resetting sessions. And there are still some vestiges of people on the internet that actually do dampening, where they look at unstable prefixes and they will not listen to prefixes that have been going up and down, addresses that are going in and out of advertising. And if you're very multi-homed and you're fairly unstable, there are some dynamics of BGP that there was a hotbed of research 10 years ago that people have sort of stopped looking at about the dynamics, where it can take a long time if your router goes down and you have 8 transit providers, it can take a long time when your router comes back up to reconverge. I'll say that while foundries can be confusing, we're not supposed to talk a lot about vendor-specific stuff at Nanog, but one of the things I'll say is very nice about Foundry is that they reboot very fast. If you've ever waited while biting your nails for a Catalyst or another Cisco device to reboot, having a Foundry reboot in 30 seconds is pretty nice. But still, if you've got 8 transit providers and you're rebooting and you're running BGP, you're going to have instability for longer than you would expect, and it's because of some weird dynamics of the BGP protocol that I can give you papers on if you're deeply curious about. So for certain people, if you don't really want to spend much effort, you can multi-home, not use BGP. But the advantages of using BGP are that you get the ability to tune your traffic. If someone's having problems getting to a certain destination, you can do something about it. You can say, hey, I don't want to get to UUNet through Sprint. And there's a way that you can type commands into the router to do that we'll talk about. So why do we use BGP and not something else? Because there is no something else. There are magic routing boxes that you can buy, little Avi in a box or something you can buy from who sells them? Route Science? Do they still exist? And there are people that sell boxes that control things, but they still need BGP. They need you to run BGP to get their food, to get the data about what routes are available via what prefixes. And there really is nothing else. You can't run RIP, OSPF between different networks. You don't make phone calls and tell people routes and put them into routers. So BGP is what's used. And the main design feature of it goes way back to when policy routing meant something very different. Does anyone remember a network called ANS? The backbone, back when there was the backbone of the internet. There were these policies about commercial acceptable use. And they didn't have to do with spam, it had to do with university traffic, commercial internet provider traffic, like companies PSI, ANS, companies that are long gone that at one time were, I guess PSI lives on through Cogent, but in terms of AS and some traffic. And the BGP was designed in a world where the government was funding parts of the net, you couldn't do certain things, and so it was designed with the idea that you had to be able to express policy. Now, the design was not intended for oh, my connectivity to UUNet sucks when I send it through UUNet. It was more designed for other things, but in practice, these knobs were put in, and it was designed extensively to allow different kinds of things to evolve because it was really back in the research days. So that turned out to be pretty good. So we call it actually, it's an exterior gateway protocol. So interior gateway protocols, interior protocols are like OSPF, RIP. How many people run, let's play guess the IGP. How many people run OSPF? ISIS? EIGRP? RIP v2? Some other protocol that I didn't mention? Teach me one. Generally, when people say, what internal routing protocol should I run, I basically say, if you're going to play iOS roulette, then what you do is you look at all your hardware, and you look at all the features that you need, and you look at the release notes, and you figure out which release and IGP has the fewest bugs, and then that's how you pick your IGP. At any scale sub 100 routers, it really doesn't matter whether you run OSPF or, in fact, you can even run BGP as an IGP, which we'll talk about. So an IGP meaning the interior protocol that communicates all the internal addresses between all the routers on your network. So as opposed to that, the BGP is the only one that's used to do that on the internet today. One place I forgot to change the RFC. There's a new RFC which I have in BGP 102, but I forgot to. Jordan, you know the RFC number offhand? Raz knew it like that and jumped all over my ass the last time I gave this presentation. So, and actually, we no longer call it a distance vector routing protocol like RIP. I think it's called a link state routing protocol or something like that. And it supports classless routing, which, how many people remember classful routing? So, okay, so the slashes and the numbers, back when 127 meant that the address block was of a certain size, and 192 meant that in Class D. But we don't really have to configure IP classless anymore routers. We live in the classless age. So the purpose is to have all networks say to all other networks, here's my address space. The routes, if you read NLRI, network layer reachability information, that just means routes. These routes are exchanged between autonomous systems, and every network that's an autonomous system has an autonomous system number. Now on the internet, from an autonomous system number, you don't know whether that network is one router wide or 1,000 routers wide. The autonomous system is a bunch of routers owned by the same organization that are configured by the same set of people using the same set of tools. The reason it's important to multi-home is because the one set of people can have brain freeze in one way, the one set of vendors they use can have brain freeze in another way, the policies that they use and the methods of configuring their routers can be wrong in yet another set of way, the fiber that they use to connect their networks may be wrong in another set of way, and you're looking to get some sort of operational diversity. And that all comes, if you read a definition of a network, it tends to be a common set of stuff. So it's a network that has a bunch of customers and a bunch of backbone, and they have a number. So it sounds like you all have ASNs. How many people have a 4-digit ASN? Is there anyone in the room who has AS4969? That was my old ISP, and it actually was bought by someone who reclaimed it, and then someone registered it, and so someone has my old AS. They've actually been pretty aggressive because most people don't want 4-digit AS numbers, so they've been pretty aggressive at reclaiming old 2-digit and then bringing them back. So in BGP, these routes are exchanged between networks, and when the routes are exchanged, the autonomous system numbers are stamped on the way out. So when a route is inside your network for your network, it has the AS path length is 0. There's no autonomous system number already on the route. When you advertise the route, that's when the router puts it on. There actually are ways that you can configure BGP to reflect routes around where it doesn't add BGP route, it doesn't add autonomous systems to the path, but that's something that people typically do more for research and collection. In general, in practice, if a router is re-advertising a route, it will stamp its own autonomous system number on it for a couple reasons that we'll talk about. In BGP, there's no concept of pipe size. The only congestion control is if a link gets so full that the TCP session that is BGP can't stay alive, then the TCP session will die, and all the routes will go away, and all the traffic will go somewhere else. One of the things that a lot of people get into when they start looking at routing is not believing how simple it is. It's just a bunch of simple rules that you can learn that are involved with a bunch of vendor bugs that you will see occasionally. And if you can run through it in your head, you can generally figure it out. But when most people start getting into it, they think there's some magic that the router will say, oh, that link is too full, let me move some of the traffic. But it's sort of like a rev limiter, on the engine. It'll quite happily just fill the pipe until it can do no more unless you do something about it. Monitor it, move the traffic, do something. And when you see routes in your routing table, you can't look at how many routes you get, and that doesn't correlate to traffic. Well, it does correlate to traffic, but not evenly. And there are some networks you'll get 1,000 routes from, though you'll do less traffic than a network that you get one route from. So you can't simply look at the table and just look at how many routes or how big the ASs are, how many times the AS path is in a given path to see how big the network is. You actually have to know something about who that network is and how much traffic you send them. So why does the AS path exist? Well, we talked about the policy, about wanting to be able to implement policy, and that's the second reason. The first reason is loop detection. So if we didn't have the AS path, then you could advertise a route, who would advertise it to someone else, who would advertise it to you, and how would you know that it came from you? This actually is a problem that we'll talk about in internal BGP. When you have BGP running between your routers, the AS path doesn't get updated. So as a result, when you speak BGP internally, you're not allowed to advertise your own routes to yourself because there's no built-in loop detection. But on the internet, the loop detection is built into BGP as a standard feature. Now this actually is an interesting thing because how many people have a network where they have multiple POPs that are not physically connected to each other via backbone? So disconnected POPs. If you wanted to, let's say you have a San Jose POP and an Ashburn POP, and you have 10 gig between them, and you have multiple, you have a transit at site A and site B, and you wanted to be able to go over the internet if that backbone link died, and let's say you had address space at A and B were in separate address blocks, you still have to VPN or do some other routing solution because the consequence of the loop detection in BGP is that if you use the same autonomous system number at POP A and POP B, and you have separate transit, but your connectivity between the POPs goes down, POP A is not going to see the routes for POP B because you're both using the same ASN. So it actually is a supported configuration of getting autonomous system numbers that if you have disconnected POPs, you need discrete ASNs, or you need to build a VPN so that you can run an internal BGP feed out over the internet. And then you have to be careful that you don't build the tunnel and route the tunnel through itself and the wormhole closes and your router explodes, which I've done a number of times. So setting policy, that's the other reason. So you look at the route. It gives you the ability to look at what you're getting from someone and say, oh, my U unit's going here, my sprint's going here. You come to know the ASs. And when customers complain, state of the art is people say, hey, I'm having problems with the network. And you say, there are no known problems on the network at this time. And then if there was a big problem, maybe the next day you'll call them back and say, the problem that we didn't have is all resolved now and should be better. But if you hear many, many complaints about the same destination, then you say, oh, they're all behind Sprint. Where am I sending my Sprint? Show IP BGP reg _1239 _. Oh, that's going to my Cogent connection. Let me grab 1239 and send it through my end layer connection. And you do that, we'll show you the configs to do that, you say match 1239 and set the preference higher somehow, and then all your outbound traffic to Sprint will go that way. That pretty much is state of the art. There are some other things that people do, the magic routing boxes. People have static route injection systems, but pretty much we do network-to-network connectivity, which maps reasonably well because the congestion points tend to be where people peer with each other, or don't peer with each other, or get full, or by transit, or have flat pipes, and typically don't break down by POP within a remote network. So that's useful about the AS. And when you're routing Fugros, you can just look at a routing table and get the sense of where your traffic's going. So if you are 4436, you may have a bunch of external connectivity. and then there's other networks that connect to each other. All the routers are hockey pucks because that's the Cisco Visio thing that everyone uses. If you are more complex, you may have more than one router. You'd have an IBGP mesh inside AS4436, and to the outside world, those other routers would be invisible because your AS just looks like you. So the routes are over peering sessions, and there are keep alives that get exchanged. So when BGP comes up, it says, hello, I'd like to talk to the other end. And if the other end has been configured, then it'll say, okay, and then you start talking. Then you send each other all your best routes, and then over time there are keep alives. And then if something goes really wrong, one end may say to the other, hey, I'm going to break the connection. Hey, I notify you that I've had some kind of bad route from you, and I'm going to break the connection. And then it starts all over again. Inside these peering sessions, the routes have attributes. They have attributes like, what is the prefix? What is the local pref? And we'll talk about those. And BGP also is a little bit different between not the actual packet format, but the semantics, the meaning and the ways that BGP works when you're talking to other people versus talking to yourself. And one of the biggest things is when you're talking to other people, the default is to give full transit, to announce every route that you have. If you have no filters, you try to peer with someone with no filters, you will give them transit. You will give them all of your routes. Internally, because there's no loop detection, when you run BGP internally with IBGP, you actually won't advertise all of the routes because of some rules that we'll talk about, because there's no loop detection in the AS path. So in BGP, there's only one best route for a given IP block at a given time. And the best BGP route is not always the best route in the router. Let's say you have a route to destination A, and you're via BGP, and you hear it from A and B, but you put a static route in saying go to C. That's a case where the router may not be using the best BGP route, so the BGP routing table is floating over here, and BGP could tell you what the best BGP route is, but you still may not be using it. So once a session comes up, all the best routes are exchanged. Then over time, just the topology updates. So you can only exchange the best routes. Has anyone had a customer who said, I know you're multi-home to A and B, but I want full transit, but I only want routes from A? I've had that happen a few times in the past. They say, I don't like your skeezy provider B that you use for backup transit. I don't ever want to see any of their routes. The problem is you can't do that. The routers are designed to not allow you to lie. If I gave you a route that I don't believe, it's just setting it up for routing loops, which is something that we really want to avoid. So if I am in a POP and I have BGP from A and B, and I try to roughly mix it up, and I put a filter on saying give my customer only the routes from A, they're only going to get half the routes. Now I can still send them a default route, but if they themselves are then multi-homed and they wanted a full table, I can't give that to them. And that's because BGP can only exchange the best routes. The other corollary of that that's important to remember is if you have customers, you must make sure that you always prefer the customer's BGP route, because the customer is paying you to get their address space announced to everyone else. And if you don't believe it's the best route, you can't advertise it. So when you design your router configurations to say, oh, I like this provider better than that guy, and I peer with him, and I want to make sure I prefer that route, always make sure that your customers are the most preferred, or suddenly they'll be paying you, but you won't be announcing their address space. So inside a router, there's multiple different routing tables. There's one for each protocol, like BGP, OSPF, ISIS. There's the actual routing table, which gets the result of the mixing of all those other routing tables. And there's the forwarding table, which has even less information that actually goes out to the line cards or to the central switching engine. And every time routes go from, say, BGP to the main routing table, they lose like AS path and other protocol-specific attributes. And when they go down to the forwarding table, all it is IP address basically and destination. Or if you're doing fancier policy routing, you may have source IP and ports and things like that. But every time it goes down a level towards closer to the hardware, you're losing information. And when you're debugging, it's important to remember this model, because you may do a show IP BGP, but then the traffic isn't going where you think it's going. And that's because you need to do a show IP route, because there is another route that's actually overriding it. And it may be that someone, hopefully you all talk to each other as you configure your networks, it might be that someone in your network did some redistribution, or they put a static route to fix something, and they're conflicting. So basic BGP configuration. You've got to have, if you're going to peer with someone, you have to have an interface you're going to peer with them on. And you have to create the BGP route. So there are a few different ways to create the BGP route, which we'll talk about in another slide. Simplest way is with a network statement. Cisco still hasn't updated their CLI to allow you to use CIDR notation everywhere. So sometimes you'll do 255, 255, 255.0, sometimes you do /24, sometimes you do 000, 255, and presumably they'll get with that at some point in the next decade. And then you'll create a neighbor session that says, hey, I'm going to peer with this guy, and I'm going to have some prefix lists, I'm going to have some filters that define sanity. Because remember, if I turn on a peering session by default, anything they send me I'm going to believe, and I'm going to send them everything that I have, which is probably not the policy that you want. If it's a customer, you might want to send them everything you have, but you're not going to believe everything they tell you, because what if they're telling you that they know how to get to the whole internet? That would be bad. And if they're a transit provider, you may want to hear everything that they have to tell you, but you most assuredly don't want to give them transit to the internet. So one of the reasons that I started talking about BGP and writing articles was because back in the 90s, when I was getting into this, 95, I was trying to read the Cisco documentation, and the more I read it, the more my eyes bled, because it was all very specific terminology, and I didn't have the dictionary to actually understand it. So my first peer was UUnit contacted us and said, would you like to peer? So I, said yes. They actually meant to contact someone else, but we were going. They had an open peering policy at the time, so they would have peered with us when we had gotten to them next week. But and I went to the guy who I was working with and showed him a config, but he didn't want to help me because he didn't actually want me to go do my own peering and stop sending all the traffic for him, even though he was using my mazed connection, and it was a long, complicated story. And Andrew Parton, who at the time was at UUnit, was very nice, and he said, I don't think that you intended to send me a full routing table from case, so you may want to go back and look at that. And then once I saw what was going on, I reread the documentation some more and figured out how to do the filters. But there are still people who feel that fundamentally the more networks that do BGP, the worse the internet will be, because they don't want competitors and amateurs. But what's interesting is we see the biggest outages that actually happen are the very largest networks doing large-scale mass nuclear destruction of the internet with route redistribution and router bugs and stuff like that. So it took a while, but you learn prefixes, filters are important, and then we'll talk about in this presentation some of the filtering that you can do. So the most fundamental attribute in BGP is the prefix. So what IP addresses are you talking about? The AS path we talked about, it's the list of autonomous system numbers that accumulate as a path is traversed. So when 207, 240, 0016 is inside 3847, it doesn't have, it has no AS path, or it's null. There's zero length. In Cisco speak, the way you express that is the same as in VI. $$ means null, nothing. It means start at the beginning, start matching at the beginning, and then match at the end with nothing in the middle. And that's the way your routes look inside your network. And when 6201 hears it, 3847 is already on it. If the 3847, the network in the middle, is advertising a 701 route, then when it's heard at 6201, it's going to have 3847, 701. So the ASs get built up. There are now 4-byte ASs, which are somewhat more practical, of more practical importance than IPv6, because they're easier to use and being allocated, and we may run out, and probably it's an easier hurdle to make the internet work with 4-byte AS numbers. So they probably will get used pretty soon. As I said, when pattern matching ASs, caret means match at the beginning and $, means match at the end. So caret $, is the null path. An interesting thing to note in Cisco speak, though, is that when you're matching, when you build router configurations, or you do show IP BGP reg 123, that will also match 1239. Even though they are numbers, when you use router commands for configuration or debugging on Cisco's, they're treated as just ASCII text. So if you want to delimit, if you want to say, I mean 701 and not 701 star, which will be 718 also, which is another big network, you do underscore 701 underscore. Underscore means beginning or the end or the middle. It means break. It means it says that AS number. So 1239.4436 is how a Sprint customer would see NLayer, and the next one is how a Sprint customer would see NLayer's BGP customer route. And then inside Sprint, it wouldn't have the 1239 because that 1239, Sprint's own AS gets stamped on the way out. Next hop is another attribute that you'll see. If you do a show IP BGP, you'll see the next hop in there. And it's the next hop to get to. Now, if you're running external BGP, that next hop should be the IP address of the device you're talking to. In exchange point situations, how many people are at exchange points? Shared LAN exchange points where there's a 24 or something like that? So the next hop trickiness comes in when you're at a shared LAN exchange point. Because unless you do something to reset the next hop, the default behavior of BGP is if I'm giving you a route and I know that you're connected to the next hop because I'm peering with you over that same 24, I'm not going to reset the next hop. And the effect is if you have providers A, B, and C, A can give B a route from C, and B will send that traffic directly to C, and then you get all sorts of badness, which was really more of a 1990s kind of theft of service and denial of service type thing, but it's still not desirable. So with eBGP, often you'll see people say next hop self, even though you don't need to. It's belt and suspenders, just like saying BGP version 4. When you're running iBGP, the next hop actually is important because the way that these routing protocols are stacked inside the router, when you run a larger network, BGP is typically not routing the packet hop by hop by hop inside the network. The packets come in, and BGP says, oh, to get here you go to IP-foo, and that is my Sprint connection in San Jose. Then it does a recursive lookup in your internal routing table to say, oh, what direction do I go to get to this IP address? Say, oh, well, you take this 10 gig over here. You go to that router over that path. So with eBGP, in a simple configuration, if you only have one router, it's always going to the next hop's going to be the guy you heard it from. But when you start having multiple routers, the next hop will typically be an IP address that isn't directly connected to that router. It's actually somewhere else in your network that you're going to look up again via OSPF or IBGP or IGP. Well, excuse me, OSPF, EIGRP, RIP, hopefully not, or at least RIP v2, something like that. The MED is another one of these attributes. It's a way that people can try to give you a hint about which path is better. Let's say you peer with someone in two places to get an idea of where the route is closer to. The problem, there are a lot of problems with MEDs, and the basic problem is the MED doesn't mean anything in particular. One network could use the MEDs 1 and 2, and one could use 1 million and 4 million to mean the same thing. So you can't compare MEDs between providers, only within a provider. There's been some problems in BGP when people try to actually compare MEDs as a primary metric, but for the most part you don't have to worry about MEDs, and if you are worried about it, you can just turn off actually using the multi-exit discriminator. It was a nice concept, but it's not much used in practice. The origin attribute is another one of these weird ones where it effectively becomes a little bit like a half of an AS path length. It's used as routers try to decide when they hear two ways to get to a given destination, which is better, A or B. But typically you never set it. The only time I've ever seen people set it is when they need more revenue, and they'll actually reset it outbound to their customers so they get more traffic inbound to them. So the origin is set based on how the route got into BGP, but again, it's typically not really very used. But you see it when you see the question marks at the end of your show IP BGP, that's the origin that you're looking at. The wait attribute was originally not part of the BGP spec. Cisco introduced it, and you should pretty much never use it. In BGP, at any kind of scale, you pretty much rely on every router getting the same set of routes and then making some decision and then all the routers communicating with each other and then not having routing loops. All the routing protocols are designed to avoid routing loops. The problem is that weight is local to the router. If you set a weight on a route because you really want to make sure the route never goes a certain way, then that weight will be local to that router, and someone could be pointing a route to you that you're pointing back at them that in normal BGP you'd never be able to do. If you use the local pref attribute, which we'll talk about, local pref is re-advertised. So if I set the local pref higher, then I'll either advertise it to you or I won't advertise. I'll hear your local pref and prefer it. But weight overrides it, and you can get into serious problems. So I don't know. Has anyone used the weight attribute in recent memory? I keep hearing, I always hear someone always comes up with an example of why it's important for load balancing or something, but talk about that. But generally, I'd stay away from it. The local pref is pretty commonly used. How many people have purposely reset the local pref on some BGP routes in their network? Okay. How many people have done AS path padding to do traffic balancing in their network? So those are the two main ways that you actually look at moving traffic. Local pref is a number that goes on the route, and it's designed to be set by you. You don't hear the local pref from some other network. The local pref is local to your network, but not to the router. It's local to your network, but all the routers in your network exchange that local pref so that they can agree on it. And it's a way that you can do something like say, oh, if it's a 1239 route that I heard on this peering session, set the local pref lower so that I don't prefer those routes. So that's pretty much the main purpose of it, is to do traffic balancing. There's a downside of that, which is because local pref is evaluated before the AS path length, before how far the route is from you. If people are trying to send you semaphores saying, hey, I don't like this route, don't use it, by putting 50 copies of their autonomous system number in the AS path, if anyone's ever seen that, local pref ignores that. So there's this whole Zen question of, should I honor these things? Should I not honor these things? Most people use local prefs because fundamentally, if you want to reset things and you have multi-home customers, they do not like it if you start messing with the AS paths because, hey, they may want to do that. People don't want to get you putting 701, 701, 701 in front of your 1239 routes or your AS in front of the routes because they. So the carriers use local pref, and local pref does ignore some of these things that people are trying to tell you, which makes it more difficult on your inbound load balancing. So I wish I had a simple answer. That's just the way that things are. One very subtle thing, if you care, if you've ever done a show IP BGP, and sometimes you'll see local pref 100 and sometimes you'll see empty, if there is no attribute, remember I said a BGP route is a bunch of attributes, it's possible for there to be no local pref attribute. If there is no local pref attribute, it's as if it were there and 100. So if there's nothing in that column, it means the same as if it was 100. It just means that you didn't set it explicitly. And I'll show you a chart of some ways that you can use that. Oop, I keep going up instead of down. So iBGP versus eBGP. Very strange. It's promiscuous with external routes, but it's a little bit more subtle with iBGP. And the corollary is you must always filter your sessions. There are some routers which will, when you create BGP sessions, turn them up, down. One good practice is if you're not going to apply the entire BGP clause at once, then as soon as you configure it, shut it down. Because if you don't have the filters in, you can get routes or start advertising routes, and when you apply them, anything that already went out is going to stay out. BGP starts doing its thing, and then over time, all it sends is changes unless you issue a command to cause it to redo things. So you have to strongly filter eBGP sessions. So when everyone's internal to the AS, it's iBGP, so you have different topologies, exchange points. So eBGP only talks to routers that it can directly see, unless you do something called eBGP multi-hop, which you should, again, almost never do. There are some cases where you might want to do it for load balancing. If a provider tells you that they want to put you on a device that can't speak BGP, you typically should be running away because it's just fundamentally, philosophically, it's bad to be on a router that has to be coddled to actually make the packets go the right way. In today's internet, we really want all the routers to know where the packets are supposed to go. The reason that people used to do that more was, let's say they had a router that could do, a switch that could do layer 3 but couldn't hold a full routing table, then you would actually, it couldn't give you a full routing table. It would take a default from some core. You'd be connected to the actual switch and have an IP address that would do layer 3 routing, but you couldn't peer with it to get the routes. You'd peer with the next router on. But that's, again, it's just a very dangerous situation because routers can and do screw up in various and wondrous ways, involved by software and user error. And when things like that happen, the router in the middle may have the default route, and you may be getting route, or you may be getting the BGP routes, but the router may have lost its default route. You're sending packets and they never get anywhere. So you typically don't want to be doing that. So eBGP sends the best route. Without filters, you're going to send all the routes. And it sends all the important attributes, but not local pref. So prefix and AS path and next hop. And it adds the AS on the way out. Usually it will rewrite the next hop, but again, if the route and both peers are on the same network, then it won't rewrite the next hop. So that's where you use next hop self. iBGP can talk to routers many hops away, because you want your router in Equinix and San Jose to talk to each other even if they're not directly connected. But it can only send routes that it creates with a network statement or that it heard from a third party. So let's say that you have San Jose, Chicago, and Ashburn, and you've got routes created at all 3 places. You can't simply have San Jose peer with Ashburn and Chicago peer with San Jose and expect Chicago's routes to be heard at the other site. And the reason is there's no loop detection. Because the AS path doesn't change and route reflectors weren't built into BGP in the first place, iBGP isn't allowed to send my own routes that I heard from another router to another internal router. I can only send it if it's a local network statement or I heard it from an external source. So that can be a little confusing, but the corollary is that you need a full mesh. All the routers in your network have to peer with each other, and that's a scaling topic. That's how do you scale BGP. iBGP sends all the attributes except weight, leaves the AS path alone, and it doesn't touch the next hop. You can change the next hop if you want to, but by default, it does not change it. So, moving on. How do routes get into BGP? The main way is network statements. Does anyone create routes in BGP by redistributing from another protocol? So that's another way that you can do it. Route redistribution is a wondrous thing that has the opportunity to bring down your whole network. There are some, in particular, some Cisco bugs that you really have to watch out for, where if you type no redistribute OSPF route map foo, it may, in some versions of iOS, it has taken out the route map foo but put the redistribute OSPF in, which can be a bad thing. So there are some trickinesses that you have to watch for. In general, people use network statements, networks A.B.C.D, with a mask if you're classless. Now, you may also say network A.B.C.D with a mask and route map. And when you get more advanced, you may be using local prefs in communities yourselves. So when you create a route, you may set the local pref to 200 and set a community that says, which we'll talk about communities, that says this is my customer route. But the basic form is I have a network statement. And it makes scaling easier. Actually, this is an old, forgive me as I update my slides, please. That was an old problem. And the trick with network statements is you have to have an internal route that exactly matches the network statement to cause it to exist. If you just type network statement but there's no static route, it won't exist. So if you have a 17 and you want to advertise that 24, but there's no route for that 24 on that router, it won't create the network statement. You have to create it, and typically what you'll do is ideally, even if you do have an interface that 24 is on, you'll create a static route putting that network that route, that /24, let's say, directing it to loopback or null zero, because you don't actually want that network statement to go away if the interface dies, typically. So let's say that you have a line carrier problem, your optic is dying, and every few seconds the link goes up and down. You do not want that route flapping in BGP. It's unkind, and it can cause stability problems for that IP block to be reachable. So, I think we went back in time. Okay. So BGP policy control. So to decide what routes you can and can't send to other people, you use different kinds of filters. There's prefix lists, which are lists of routes that use modern syntax. There are some distribute lists that use dinosaur syntax, which we typically don't use. There's AS path filters that filter based on AS path. And then route maps that are little programs that let you put things together to create more complex policy. So the prefix list is just an IP address-based accept or deny that lets you do some filtering. So you say, I'm going to permit my routes to be advertised, and then by default, I'm going to deny everything else. You may also have some prefix lists that are designed to deny. What do you want to deny on the inbound? You want to deny RFC 1918 space. You may want to deny unallocated space, although that's increasingly dangerous as all the space is becoming allocated. And the other thing that you really want to deny is your own routes from being heard from the outside. Unless you have multiple ASs and multiple POPs and are doing that disconnected routing thing that I talked about, you don't want to allow someone else to be advertising a route, your route into you, because God forbid you might actually believe it. So you can filter based on IP addresses. You can also filter based on ASs, and forgive me again as I have a typo here. So the two most basic ones that whenever I start configuring BGP, I try to make sure that I've always got an access list that says permit everything, and an access list that says deny everything, and an access list that has the list of all my ASs. So it's nice for your fingers to be able to go, when you make someone nervous, you're typing and typing and typing, and you go, oops, or holy shit, or whatever it is that you say, and the person, goes, that's not good, he was just logged into the router. You want to have something you can apply on the session that you know that number. This is how, because you may not want to shut the session down because you may be advertising routes on it. So you may not want to say shut down, but you want to have something well known on every router that says don't send anything. Or if it's a customer, you may want to have something that says send everything. So it's helpful to have 3 access lists that you put on every router that you just know. Send everything, deny everything, and send only my routes. Those are the 3 most basic ones. And then the more advanced, then the next ones you'll create are, UUNet sucks through Sprint. Okay, I'm going to make an access list that says match 1239.701, and then I'm going to apply that, or just match 701, and then that's another reason that you would create an access list. So the regular expressions, dot, very similar to if you use, anyone use VI? Unix shell stuff, so very similar. And caret and $, basic ones, and then underscore. Underscore means delimit. So beginning, end, it just means it's a way of making a number into a number. So underscore 701 underscore means only the number 701, not 7018. And then there's many more advanced things that you can do with them that can make your eyes bleed. So be careful, but you have a lot of flexibility. So ASPF filtering is a way to say, I don't want to hear something from someone, or I do want to hear something for someone. So in this configuration, if router B over there actually wanted to block only hear 6201 and 6202 and not anything else, just was doing some peering and wanted to make sure it didn't get any transit routes, you could specifically permit and then deny. Or in this case, you could say deny 701 and permit everything else. It would be the inverse of that. Depends on the thing. So you build the access list and then you apply it on a peering session, which you can do directly, or you use it as part of a route map. And the route map then gets applied on the peering session. Does anyone, I did not ask before, who uses Foundry to do BGP in their network. Okay, so one of the really interesting things is that Foundry, every time you type a modification to an existing peering session, it says something like, please be aware that this might not take effect until you clear the session. So every time, if you cut and paste some stuff, you're going to get a whole bunch of garbage in line as you cut and paste. Now, one of the many wonderful things that Foundry did was they reversed. So wonderful thing that they did was they boot very fast. One of the not so wonderful things is they play with the syntax. So write mem, write won't work. You have to type write mem. But one of the interesting things is they changed the order of the route map and the in and the out. So I think on Foundry you have to say neighbor foo route map in route map name instead of route map name in. So I was one time starting with Foundry and I did a massive cut and paste, and I thought I had applied everything because you ignore all those please be aware, but it turns out it didn't take the route maps. And if you turn on BGP sessions without the route maps and you only put your filters in the route maps, then you can have a problem. And you can get things that you do not intend. So you can elect to be belt and suspenders and have route maps and still do basic IP and AS path filters, which at modern CPUs is not that dangerous to do. So again, you have a permit everything, deny everything, and permit mind. As you add BGP customers, AS path access list 3 there would add a list of all your customers. You'd have caret, 9999 underscore or caret $9999 $, and you'd build that up over time. So route maps. Route maps are a way of getting more complex policy. So you have a route map name, and then you have different clauses. Each clause can, if the things in the clause are true, it can either match or deny. It can either accept or block. And then inside the route map, you can not only match on things, but you can also, that's how you reset attributes. If you want to change the local pref or change the origin for some reason, the route map is what you would use to do that. And I have some examples we'll show you. So if the route map begins with permit, if the prefix passes, then it's permitted. And if it begins with deny, then if the prefix passes, then it's actually the reverse is true. It's denied. So how does BGP select routes? If you are multi-homed, terminology is that you're going to have multiple paths to every prefix. So it's not that you're going to have multiple prefixes. You may have multiple prefixes for a given IP address, but typically you'll have the same /24 for a given IP address, and then which path are you going to prefer? So the selection in general is not random. Actually, this is an area where, if you'll excuse me again, there's some different implementations that do things differently, but often people say, well, BGP just figures it out and it's random. It's not random. There's rules. You can make it random if you want to by doing things that you're not supposed to, like having every router in your network have the same router ID. That would be bad, but people do it because ultimately router ID is used. There are some routers that wind up, if there's a tie, using the route that you most recently heard still, which can effectively be making it random. But in general, the routes are not going to tie, and you'll be able to easily figure out why traffic is going where it's going. So the basic rules are you can only consider multiple paths if the prefix length is the same. If there's a more specific prefix, you're going to prefer that. You can only consider it if you can get to it. So if you are unreachable to the next hop, you won't be able to consider that path. And then prefer a route that's originated locally. And then generally speaking, the route with the shortest AS path, then the med, then router ID. That's assuming you didn't set something else. But if you set wait, local pref, or AS path padding, look at those. So local pref before AS path, and then wait after that. So setting the local pref overrides how far is the AS path. And again, when you're talking about AS path length, there's no concept of performance or bandwidth or goodness or color or anything like that. It's how many numbers are there in the path. It's not what's the word count of the line. It's just how many network hops does it appear. So if you want to make a path look less good, you make the number of hops bigger, and then it's going to be less preferred. So the full thing is here. So you see local pref before AS path, then origin. So we sort of say origin is like half an AS path length, because it's not random, but it is a little bit distributed, and you get some load balancing that does happen due to that. So let's say that you want to prefer some routes. You actually want to say that I'm going to prefer to get to depreference 701 from a different peer. There are a couple ways you could do it. One way is you could say, I make a route map and say, I'm going to depref 701. What I'm going to do, I'm going to match on AS path access list 50, which says permit 701. So when I hear a route and it's got 701, I'm going to prepend from 4436 that route. So that'll be an extra AS hop, and I'll send a little bit less traffic that way. Another thing that you could do is say, if I hear that route, set the local pref to 90. It's below 100, and then it will not get used. That's going to influence more traffic than the first one. Now, again, if you have customers, you may not want to do the first one because they'll see those extra AS path hops. If you feel very religiously that you should honor all the AS path lengths that you have been given by the other providers who have been graceful enough to give that to you, then you may not want to set the local pref. So router vendors used to be much more complex. Today, most people are running Cisco Catalyst in the data center. A lot of people are using them outside the data center too because they're a very cheap way to get 10 gig. One of the nice things is they do graph VLANs, which some other router and switch vendors don't, and everyone knows the CLI. The Juniper has a more robust, maintainable CLI. It's got rollback, and it's a lot more flexible in some ways. It's a slightly different paradigm. And the prices have come down some, although generally they're more expensive. You can even use PC routers. The Viata is supported in an open source project, or you can use Zebra Quagga. And then Foundry and Force 10, there are other switches that can do routing that do work, but they've all got gotchas. And most of the gotchas have to do with the fact that the syntax looks like Cisco, except it subtly isn't. And so that confuses your fingers at a time when you may need to be fast. And sometimes it can cause things like not having the route maps applied because you don't even notice, because there's real differences that can cause problems. The other thing is that if you bill customers, a lot of these other vendors don't actually support full traffic counting on VLANs. And that can be a problem for people as well. So SFlow is great for doing DDoS and security, but not as great for billing people, especially if you get into a billing dispute. So typically Cisco 6500, 3BXL, the prices have gone up a little bit, but still not that expensive for what it is what people start with. So for small network, you typically get a pair of routers. You could get you can get machines that have no problem switching 10 gigs of medium-sized packets, routing even 10 gigs of medium-sized packets on a PC platform, a Core i7 box even, but Cisco's are relatively cheap, and you'll have to do what's right for you. So, first thing to do when you're actually multi-homing is think about what you're doing. So don't just say, oh, I now have address space in AS, let me go configure the routers. So what are you trying to advertise? What do you want to do with the routes that you get advertised, that you are advertised by someone? So plan the config and then implement it. Work with your providers. You want to advertise all your routes and all of them, but only your routes. You don't want to advertise other people's routes. So get that together and get the list of ASs if you have downstream customers together. And you want to accept all the routes, and initially you'll just let the router sort them out based on AS path length. I think I asked this, does anyone have routers that are constrained as to how many routes they can carry that run BGP? So there are things that one can do. I do have a couple that are crippled. And I work with some networks that have 2,000 routers, and it's the second percentile that's killing them. It's the 20 devices that still haven't been upgraded, they're killing them. And so as a result, they actually block 24s in a bunch of different places to make sure that they don't have problems. So never black hole. This is bad. Raise your hand if you've ever accidentally advertised someone else's address space. The room is full of liars. So you don't want to do that. That's bad. Most of the time, I've seen people advertise address space on purpose that is not theirs. Usually it's unallocated space or space that someone's not using, but usually the times that it affects things is by accident. You just type in the wrong address. And while you count on your providers to do filtering, what if they don't? So I think we understand that. So the reason why it's very dangerous is because, let's say you're buying from Unionet, and they put your bad route into their route filter. Well, they have to believe that the route from you is the best one, or they couldn't advertise it to Sprint. Because BGP only lets you announce a route that you believe is the best one. So they are really, in their whole network, going to send all traffic destined to that destination to you. So you don't want to be black holing YouTube, or, again, well, Google has a lot of lawyers, and you'll be getting a lot of traffic, so that'll probably impact the stability of your network. I think we will skip. So basically, when you're multi-homing, you need address space and AS. You test the configs. You basically show that you can announce your routes. Typically, you'll bring up BGP to your providers, and they'll hear the route via BGP while still having the routes in for you. And then once the BGP is established and everything is running fine, they'll take the static routes out and you'll be running fully on BGP. So initially, or even permanently, you might want to have default routes. How many people have default routes in their network? Wow. It's adventurous, but there's reasons plus and minus. So, or how many people accept a default route from their provider? Have a default route via BGP from their provider. So I'll give you the philosophical pro and con. The pro is, well, let's say that you have a provider and their POP is destroyed, right? Or their POP has a power problem, and then their router is down and then starts rebooting. If you have a default route to them, you may be sending them packets for which they don't have routes to help deliver, and they're just going to drop them. So if their router is in the process of coming up, then they may be able to bring up the BGP session with you, or in fact, if you have a static route, the link may come up, but they don't have any routes, so they can't send anything anywhere. But now let's say it's the reverse problem. Now let's say it's your router that has the power problem. And so you have to ask yourself, who's more likely to have the power problem? And now your router comes up, and now it has to wait for BGP to come up and get all the BGP routes. There are some people that would prefer, that say, my providers are more stable than I am, and so my router is more likely to go down because, maintenance or whatever, so I would rather, if I don't have any BGP routes, at least have somewhere to send it. And most edge networks that I know of typically do have default routes as a backup. Now they run BGP, so again, as more specifics come in, then they'll start using their providers. So if the provider has a problem, and you have a problem, like let's say, then you may have a default route sending traffic to nowhere, but you don't have anywhere else to send it, so it's not a problem. If one of your providers was up, you'd have the route. So it's an interesting philosophical discussion. So it sounds like most people don't care about default route load balancing because you're not doing it. So now you list your routes, and then you put in hold-up routes. Again, you don't want to be creating the route in BGP by mirroring an interface, because if that interface goes down, the BGP route goes away, and that's bad. You want to put some routes into null zero or loopback that keep the route there. And then you want to make sure that you've got a permit deny. You want to make sure you can permit everything, deny everything, and then permit just yourself, so you have that as a tool. You create the routes in BGP, and then set up the neighbor. But when you do set up the neighbor, I would say, again, especially if you're new to it, set up the neighbor and then shut the session down. So neighbor foo, AS foo, AS bar, and then neighbor IP address shut. And then you can unshut it. So neighbor session, who am I peering with? I'm going to peer with them. If you're paranoid, version 4, next top self, you don't need that typically, but you can set that. I'm going to set a prefix list that says only allow my routes to go out and don't allow bad stuff in. So RFC 1918, don't allow my routes to be advertised from the outside world. And then I'll use those filters. So I'll say filter 3 out is my routes, $$, and then filter 1 in is permit everything, which you don't need, but you can look at it and see, oh, the policy on this session is permit everything. So it's useful to be able to know that by just scanning it. And then test it. do a show IP BGP, see that your routes are in the routing table. You can't advertise them if they're not. Bring up the session, show that you're advertising them to your neighbors, and then go to, sorry, that's another, this was adapted from an earlier presentation, so I'll give a list of current looking glasses. So go to a looking glass and see, or route views, and see how your route is being seen. So preferring routes we talked about. Controlling routes on the inbound is a little bit less subtle, because what people often want to do is say, I have a customer who's on Time Warner Cable in Texas, and they're having a problem getting to me, so I want to make that customer get to me via level 3. How do I do it? But I don't want to change anything else in my network. So the answer is you can't. You have really, really very big hammers that you can apply. You can basically either start by AS path prepending. You can say, I want the prefix that covers the server they're trying to get to be seen as one hop further away by Time Warner Cable, which is all great if you have a direct relationship with them. If you don't, then if your provider does and has a flexible community system, which we'll talk about in the next presentation, then you may be in luck. But otherwise, you may have to move all traffic to that web server to a pipe that's not level 3 to fix that one customer's problem. So if that one customer is the CEO and they pay you $20,000 a month, you might do it. And if they're a gamer complaining about lag to a employees hosted server, you probably wouldn't. So in application level load balancing and CDNs, wonderful whole separate topic about how you move traffic, but in BGP, there's not a lot that you can do. So either you advertise it more specific only to one provider, and the other problem there philosophically is if everyone did that, the routing table would have all sorts of extra crap in it, and that would be bad. Or you can, and I've got some snippets for that, or you can AS path prepend. So let's say you did want to advertise a more specific. You'd then have two separate prefix lists. Sorry again. One that's got the 23 and one that's got the 23 and the 24 and one that's got the 23, and you'd say one provider I'm going to send the 24 and the 23 and one just the 23. Or you may say one I'm going to send the 24 and one I'm going to send the 23. You can do different kinds of breaking up, but you need to make sure that you don't make yourself less redundant. So typically you want to send the 23 to both places and send the 24 only to one. Or for people trying to do traffic level load balancing, you may send the first half to one provider and the second half to another. Again, not very friendly and in some ways less redundant. When you do that kind of specificity, there is topology on the internet, and broadly speaking, AS path matching often does find a better path. And when you do advertise more specifics, you break any concept of how close network-wise the relationship is. Now that's not, again, 100% that the shortest AS path is the best path, but overall it's better than 50% correlated, so you want to think carefully about breaking that level. Now if your customer's Akamai, then it doesn't matter because they're doing their own load balancing, and how you advertise their address space just has to be reliable enough that there's multiple paths. So the second way to influence traffic is communities, which we'll talk about in the next presentation. Some providers will let you do this and some providers won't. How many people have used a community to build a route map to do routing traffic preferences? Okay. So they let you do things like say, please don't advertise me to your peers, or please prepend the AS path by one when you send it to UUNet, which you have no other way of doing because you don't peer with UUNet. You peer through you get transit through your provider. So some IOS commands: show IP BGP sum, show IP BGP IP address, advertised. Probably the most important thing on this page is the soft in and soft out. Typically, devices are getting better at doing not bringing down BGP sessions, even if users make it look like they want to. But when you apply a new policy to your BGP peering session, it's still not going to be take effect unless you issue a command to do it. And when you do issue that command, it's very important to use the soft keyword. And soft means think about what I've advertised and look at my new policy and send the changes. Without the soft keyword, what it'll do is kill the session, and the session comes back up again, which is one way to reapply the policy, but it's very harmful to your connectivity and not great if everyone did that all over the internet. One very interesting BGP skill as you look at tuning traffic is, has anyone ever done a script, a Unix type script, or an expect script to get a BGP routing table from a router? So maybe next session I'll SSH in. So something that I think everyone who does BGP and looking at stuff should know how to do is answer the question, rank the top ASs by the number of routes that I hear from each peering session, which unfortunately, I'm not a Juniper expert, maybe there's a way to do it on the Juniper, but on a Cisco or Cisco alike, there's no way to really use show IP BGP and eyeball it. That's basically it. It's actually very easy using 5 lines of Perl code. You type script foo, telnet the router, turlen 0. You want to run this in a screen session. How many people have used a screen session in Unix? So run this in a screen session because you're going to get hundreds of thousands of lines of output. So screen, control AC, make an extra screen to jump into. Script foo, telnet to the router. Turlen 0 means don't hit the more prompt at the end of the bottom. And then do a show IP BGP and run away. Hit control A space and run away. And then give it a few minutes, and then go back, and then it's done. Exit, control D, now you've got a file. Then you have a 5-line Perl or awk or Java or whatever your favorite thing is, and then you do pattern matching, and then you can analyze the routing table. It's actually very useful to be able to do that if you're moving traffic, because again, the number of routes that you hear from someone isn't the amount of traffic, but it is at least some kind of correlation that you can do if you don't happen to know who your biggest peers are. How many people run NetFlow infrastructure? Wish they run NetFlow infrastructure? And for every of the people who run NetFlow, you get top talkers and you use that to look at networks. So that's better than this, but this is a good technique if you don't run a NetFlow aggregation infrastructure. I've long thought that a sort of very cheap Arbor Lite that is more on just the top talkers, reliable appliance, or even just a service people could point their NetFlow to that would also do a little bit of DDoS type stuff would make it traffic engineering a lot better for people. So if someone wants to start a company, I think other people in the audience might buy that service from you. Some best practices, which we'll talk a little bit more about in a half hour. Filter. BGP TTL is a way to make sure that people can't send BGP packets to you from remote destinations. Basically, you make sure that you only talk at very high TTL to each other, and it would be impossible for someone 3 hops away to get you a packet with TTL 255. So there's some ways and some tutorials on how to use that. Next up, self BGP4. Actually, I keep getting yelled at because BGP passwords is no longer. I know a bunch of people who still love it, but a lot of people feel that BGP passwords hurts scalability because, well, you have to record it and track it, and it doesn't. I mean, BGP passwords implements MD5 on the TCP session itself, but no one's ever actually demonstrated attacks that are happening by people attacking the TCP sessions, and the TTL hack gets you most of the benefit there. Peering between loopbacks is the same kind of importance as making sure you have a null zero route underlying the network statement. You don't want to peer ideally between, if you have multiple peering sessions, or let's say you have multiple paths, you have 2 GigEs to a given provider, you may not want to peer from the actual underlying interface IP. Or even if you only have one, you still may want to use a loopback to peer with each other so that, let's say there's a temporary interruption, you hire your local dumber hands facility to come through and the keys jingle and it knocks the cable loose for just a fraction of a second. You don't want the link to go down and the session to go down. So the loopbacks inject a little bit more latency in the process where more has to go down before the BGP session will actually go down, and I'll show you some examples of that. And enabling soft reconfig is also very important. Peer groups, again, covered in the next slide set, are important to limit your CPU and consolidate your policy. As you scale, you want to look at route reflectors. How many people run route reflection in their network today? Okay. So route reflectors are a way of making it so that you don't have to have a full mesh of every router peering with every other router. So it injects a new attribute which does the loop detection for you, and special things called route reflectors that can maintain that. You should always pref your internal routes over BGP. There are some routers that will actually prefer BGP routes to static routes or internal routing protocol routes. Don't use route flap dampening unless you understand it, because you can actually hurt your connectivity. We didn't talk about it, but use max prefix. So if you have a customer, just in doubt, say, I never want to receive more than 10,000 prefixes for them, or 1,000 or 10 or whatever the number is, because just in case they have a bad routing day. Log BGP. How many people do log BGP events from their Ciscos and stick it into? Very good. I have very simple hourly syslog code, and all the servers go into it, and all the routers go into it too. And sometimes you see some very interesting stuff. And if you do use private ASs, which we haven't talked about, make sure you don't leak them to the internet, because that can be bad. One of the things that can ding you about using weird BGP configurations or implementations is that BGP's got a number of different message types. The hello, the update, sends routes, but it's also got the notify. And when BGP hears something that it thinks is not valid, either syntactically, meaning the packet format is bad, or semantically, like, hey, he said AS0. AS0 is not allowed. Then they send a notify message, and what happens when the notify message gets sent is that the routing session dies. So imagine you have Avi BGP, which creates bad packets that Cisco thinks are bad, but Juniper doesn't. About 99% of the time it's been the opposite, but let's just say this is the case. And then the Ciscos and Junipers in the world are happily talking to each other until the Avi BGP created packets get out there on the internet. And then the Junipers think that they're fine, but every time the Juniper sends one to a Cisco, the Cisco goes, no, and then kills all the sessions. As most networks use, big networks use multi-vendors, so they'll use Juniper in the core, Cisco at the edge, Cisco in the data center, something like that. You can have real problems when that kind of thing happens, and every few years that happens like clockwork, that we have a problem like that. Who let the banker in? When did you last configure a BGP session? When did you last configure a BGP session? I'm sorry, deconfigure a BGP session. Okay. And that is it. So if you're curious, we'll talk about some of these scaling topics in the next. If anyone has problems with their traffic load balancing and would like to suggest their network as a victim, we have SSH, and we can do that during the break or during the next session. And are there any, actually I guess we have 2 minutes, any questions or topics that we should focus on during the next session? Did anyone learn something? Okay. 3 people.